period of 10 to the minus 3 seconds, its density would have to be around 10 to the 16 kilograms per meter cubed. Denser than any known white dwarf. So people were like, okay, these are not white dwarfs. So it kind of went like, they basically went like that. Okay, let's keep going. There's a nice part coming in now. So it doesn't have to be, but I think, yeah, a lot of them are spinning. Yeah. Basically, if there was not any angular momentum to conserve, then it would not necessarily be spinning. But I think the way they, yeah, basically, I think this is the reason why basically, if there is a rotating magnetic field, which would then create an electric field, which then creates the synchrotron radiation, which then shows up as like a pulsar to like some things, some certain requirements have to be met, but oftentimes they're pulsars. Yes. If that makes sense. A clinching piece of circumstantial evidence is that some pulsars are found within supernova remnants. Both. So I think it's not completely for sure known that you have to be a pulsar. But we've seen pulsars and we think that, oh my gosh, these have got to be neutron stars because of like other reasons. And so here's some more of that. A clinching piece of circumstantial evidence is that some pulsars are found within supernova remnants. Both neutron stars and supernova remnants are created as the consequence of core collapse in a massive star. So by the way, oh, thank you, Ben. Thank you so much. I do not comment much, but rest assured that I'm listening carefully. Thank you so much, Ben. Really appreciate you as well. Thank you. Ben, Reese, and Doro. And I'm sure I'm missing someone. Can their proximity to us be calculated in any way? Yeah. Yes. So basically, another thing I didn't really mention yet is because there are different types of supernova. The neutron stars are not really thought to be made unless you are doing a core collapse type of supernova of a very massive star, right? So it's almost like we've seen pulsars within supernova remnants, and we've also seen neutron stars to be supernova remnants. So let's briefly review events during core collapse. The vastness of your knowledge is actually insane. Rain Woman. Oh. Okay. So, well, I have all these books and authors who are sharing their knowledge, right? So let's briefly review events during core collapse. So, by the way, so there are people who work on modeling supernovae, like supernova, right? And there are different ways of having a supernova. Core collapse supernova is a very common one. We just kind of mentioned it, right? And now we're going to briefly review the events during such a core collapse. The iron core of a massive star grows larger than the Chandrasekhar mass. So core collapse pretty much, so when somebody says core collapse, they basically mean a massive star who has made a core of iron. Like it's basically grown an iron core in its belly. And that iron core has become bigger than the Chandrasekhar mass limit, which is around 1.4 solar masses.